interesting. Calling a private constructor of class utils batch threadsafe tracked object threadsafe unlocked tracked object cppgraphviz log node. Yeah. A private constructor of batch. And it gives access to some tracked object. So what are we in? ObjectTracker, I would say. Nope, it's tracked object. Which is which? Hey, Post Bunny. Where do all those angle brackets come from? That one closes this one, and then that one closes batch, and then I have 3 left. Hey, looks it. Okay, give up. Let's see. I start over. We're calling a private constructor of class batch all the way up to L5 closing things in instantiation, and I want that also. Copy, paste. I'm going to replace all angle brackets with square brackets. And I can at least use new vim to jump. Yeah, see, that one is the last one. Stronger. Okay, so this part is the same. And the last part isn't. This is an object tracker and this is a node tracker. But isn't a node tracker the same as that thing? Jump to node tracker. Oh, it isn't. It definitely is not, no. It's maybe derived from that. A node tracker is an item tracker node. So that is an object tracker node. Or a node is this. So yeah, it's the tracker that is used there is derived from what is used here. That's why it doesn't work. Kind of would make sense. I feel that this should also be node tracker. Too many. Yeah, that seemed to work. Seems to have worked. So next is undefined reference again. I think you got rid of a number of undefined references in the meantime, compared to yesterday. So I'm still skipping the label node thing, but this one doesn't seem to be related to label node. In item.h, tracked object, yeah, so the missing inline, I guess, in array. Inline thing being that. Label node. Label node. Didn't seem to have worked. Oh, I missed that one. It's actually node.cxx. This one. So these are compile errors again, instead of undefined linker errors. This constructor, etc. Yeah, well. Then what is the problem? The problem is no matching function for call to construct add in instantiation of function template specialization construct blah blah blah. And ObjectTracker inline.h in instantiation of function template specialization make shared. threadsafe tracked object, threadsafe unlocked tracked object, unlock node. Yeah, so we're using this one, right? So this constructor is used by trackers that are derived from this class, instead of the one that takes a batch. Thus single argument, but no tracker itself should take the batch, I think. So then here's the batch missing. And yeah, what the hell is going to call that one? Probably the same as we just had for graph tracker. Probably close enough. Oh, this one also takes a reference. I changed that as well. I already have that here. What did I just copy? I guess the whole batch. Yep, and then that is no tracker. Going to rename this, I think. Yeah, it's very hard to have consistent naming. Okay, that worked. That was not bad then. But now we have undefined references again. But again, less than before. Label node, label node, label node. Now we are stuck at label node, I think. There's one more left here, maybe. That's also label node. Yeah, and I have a definite. Oh, hey, Louis. I'm having a definite problem here with the label node. I made a .cxx. Maybe that's not being linked. That could be. That could be. Let's see if that solves everything. Label node, yeah, totally not there. I thought I had a much larger problem with label node though. Okay, now that file that I just added also doesn't compile. Call 911. Member access into incomplete type, standard shared pointer access. Incomplete type. Yeah, the tracker's not known. Okay, what is the type of the tracker here? No tracker. Well, that seems like an easy one anyway. The whole reason that it was put in the .cxx file is because that tracker is undefined, incomplete. I mean, in the headers. Dang, it compiles. How is that possible? I mean, I thought there was a big problem with the label node. I'm going to look at label node, I think. What label node? Label node. The problem with label node is that it is derived from node. Wait a minute. I did do work on it. Yeah. We just do the do write lock and write unlock trick, and I even have one now for the copy constructor. But just like the base class node in this case that takes a no lock, this one also needs that, because we even derive from label node again. So why is that compiling? Okay, unlock tracked object. Provides a constructor that is protected and accepts a no locking type. Oh, Louis, I'm very jealous. So you're sitting in a whirlpool now, drinking a glass of something cool. No idea how you're watching my stream from the whirlpool, but cool, cool. Yeah, I know what I have to do. Basically copy both. And I reworked them, but they are so ugly. This is also a weird remark here, I must say. Oh wait, I didn't see the node. If this is not the most derived class, then do not use this constructor. Right. Shall we just go over it and copy everything? I think I only need the unlock, not these two lines, but okay, I need that one. And then the label node should do this. Although it's going maybe a bit too far. Ugh. Yeah, so that one replaces this one, so we only have to do that. What? I'm calling it. Oopsies, yeah, horrible, man. How can I do that? No, we'll never know if that was causing an assert, but it should have. So I do not want those two. And this is basically this one, but with while allowing arguments, any arguments. Therefore, it's also this one. It's like both, or Hello. Yeah, something and Pranov. What? I copied it, but now how to convert it to this class? Not easy, not easy, not easy. Yeah, I'm not interested actually doing this. I don't think I am. I am not interested. Let's do undo. I thought that's derived from label node, right? So that can't compile. Maybe that's another test. Probably class members or something. Or rate.h derived from the label node. It's rectangle node. Yeah, the rectangle node is then hopefully only used in a thing that I'm not compiling yet. Yeah, well, actually. It's used in label node test and class members tests. I am compiling label node test. Don't understand it. $22, that is I don't know. Busy maybe. Oh, invalid argument. Well, that's not good. What is invalid about it? Yeah, that cannot be right. So it looks it's nonsense. Yeah, I agree. So the mutex is probably already freed or something. This is inside mutex lock, so we do up. So this mutex here is nonsense. It's a lot of fives everywhere. Even here I see a lot of fives. Maybe a piece of a stack or something. Line. Yeah, those fives are addresses. It's a heap address. So these two form an address together. On that one too. Or this one with that one, I don't know. Yeah, probably like that. So this is an address, this is an address. So it's completely overridden with something else. Well, okay, so why that? This is on the stack. yeah. Interesting stuff. How do we debug this? How reproducible is it? It would be very nice if it reproduced down till the last bit. Every time the same addresses. Well, we can hope. Let's rerun it 20 times and see how it reproduces the same address here. It does. And again. Yes. Yes. That's every time the same address, right? Stack is also very important. Let's look at this one. Also the same. No, another one. Looks to me that everything reproduces, right? Yeah. So I'm gonna go up. And then mutex here is nonsense. And it is still looks like addresses. And mutex is of course part of something. It's part of AI mutex. And we are now at line 52. So if I print this pointer, then we have this pointer of the AI mutex. I think that also that is part of an object, so I can go up. It's actually something that is returned by this function. Yeah, that's pretty weird. Mutex should this returns a reference to a mutex that is part of an unlocked, and the unlocked that we seem to be talking about here still lives on the heap. So the mutex should be living on the heap. I don't understand why it's returning a stack pointer. Really strange. So I put a breakpoint here. Is that, if I then I run it, is that then the first time that we get here is the one that is the time that we crash? I don't think so, that's a bit short. So we do continue. It's the second time that we get there. Third time. Fourth. 5, 6, 7, 8, 9. Oof. The 9th time we only crash, not before that. Let's reproduce that. Just 1, 2, 3, 4, 5, 6, 7, 8, 9, and now we crash. Yeah, so it seems to reproduce. If now I do this again and I print the same values, that is print mlocked, and I want to print that, although you know GDB. It never works. All you can do is step, and then we can print. So yeah, that's on the heap. In fact, it is very close to that one, right? It's just a little bit further, as it should be. So this should be the larger one, and if we subtract that from that one, 232. Well, that's not super close. You got to wonder if this is part of the same memory allocation. Now I think about it, I did not write libcwd for nothing. It has support for tracking memory allocation, so I could just ask it to if this is the same memory allocation or that, and if so, what it is. Yeah, but then I have to turn it on. I don't think I have memory allocations turned on right now. Do I dare to do this? Maybe not yet. Let's just continue and then print again these values. Guess that one this time. It's totally different. Totally different. Step. Print. .48. That's more like it. It's more like it, as in the same object-ish. Continue, that's the third time we stop here. So it's not the same value. That's the same values as before. Yep. And that's again the same value. So we get again 48. That's a good thing, I think. Hopefully we only get these two. Continue. 4th time. DD240. It's a new value. Looks like a new value. Step. $72. Okay. Oh, this is a ref. I just have to print a pointer. That's on the stack. What? This is not the one that crashes yet, is it? Nope. Although it could be. It's all zeros. Could be nonsense. Lost count. When is it going to be the one that is wrong? Okay, let's tab again. Print mutex. Print. Well, that's the same value that we had before. Same values. Continue. 2, 3, 4, 5. 2, 3, 4, 5. No, that's a pointer again. Yeah, now it's not a stack. This makes a lot more sense. Wow, what a difference. No, man, confusing me a lot. Looks like they're unrelated. Now we have a stack again. And this is the correct values. So that is the crushing point. Right, and that belongs to the unlocked value of this one. So let's highlight that one. And then hopefully we saw that before. Ah, dang it, we didn't. Well, we did here. Cannot be a coincidence, can it? Right, okay, so at the moment that we crash and unlocked is this highlighted thing. And first of all, if we continue, it should crash. Yes. Now run it again. And then we run it until we crash. And then it go up until we are here. And now we print this unlocked value. And it is highlighted. So that reproduces apparently. I can do it again, but I think everything is just 100% reproducing, which is a good thing. So now I want to stop here. After it prints that it constructed a const unlock base with this pointer. Why the hell would the const unlock base have the same this pointer as this one? Unlocked. Does not make any sense whatsoever. Unless nah, I don't know. Pretty sure that this is a constructor, of course. Let's just put the breakpoints on all the constructors. What the hell is that? It's all of them. There's a lot of those constructors. I think no. Can I put a breakpoint on all of them? 8 locations. Well, good enough for me, I suppose. And then I want to rerun. Yes. Continue until we see the highlighted thing. So this breakpoint here was the one, because after that it printed it. Breakpoint 2.8. Yep. And again, yes, continue. 2.7, 2.6, 2.2, 1.2, 1.8, 2.8. So here we are constructing the thing that the unlock points to. This constructs a policy mutex reference type, passing whatever this mutex call is going to return. I'm real curious what that's returning, but I guess we can just skip that and then just print the contents of this current object. Just so I want to go to the end of the constructor. Guess I can put a breakpoint on 617. I want to disable 1 and disable 2. Now we do a continue. Now we are at 617. And I did print that it did constructed object. And we still have this pointer, which is that one. And now I can print the whole thing. And then we see that it has a pointer to the primitive mutex, which is indeed on the stack for some mysterious reason. Why? That is so weird. Not only that, it's already corrupt immediately after the construction. So I would say that it goes wrong right here during the construction. There's the weird stuff. So unlocked is unlocked. Yay. Wrapping a locked node with primitive policy, locking policy. Add a stack location. Which is derived from log node, which is derived from item template and of unlock tracked object log node using node tracker, which is, by the way, a tracked object, unlock tracked object, and so on and so on. And even the tracker here points to a bad memory address. Virtual table seems to be corrupt. Use count is nonsense. Everything is nonsense. It's not just this. Everything is nonsense. Even the thread ID is nonsense. Totally uninitialized memory, if you ask me. So I think we have to look at unlocked instead. The unlocked that is being passed here is just her. Where does that come from? I'm not seeing an unlocked. We went down too far. So this unlocked here. That would be the argument that's passed to the constructor of const unlock base. Up. That is this unlocked. And that is the argument that is passed to the constructor of unlocked base. I set const unlock base here, right? So we go further up. That just tells us that it is using the constructor of the base class while constructing an unlock base tracked object. So it's the argument that is passed to this unlock base tracked object. Yeah, like no way in hell. What the hell? These args are supposed to be passed in the end to, I don't know. So not interpreted as an unlocked anyway. Not to be interpreted as an unlocked. In fact, this requires here, should stop it from doing that. It may not be a base of unlocked. It's using the wrong constructor, it seems. Or is it? It's an unlocked. It's totally an unlocked. It's an unlocked of something, but it is an unlocked reference. Or at least derived from an unlocked. Requires for any argument it is not unlocked, is not a base or equal to any of the arguments. It's not an unlocked. But this is not just any unlocked. It's the current unlocked. Unlocked being a template class, so maybe the current class has different template arguments than the unlocked that's being passed as an argument here. Well, the current unlocked is this unlocked with a lot of template parameters. And the argument that is being passed, can even print it. GDB printing template parameter packs. Oh wow, it's actually doing it. So here's the type of the first argument, I would say. I'm not sure how to read this, but there is only one argument. Maybe you can just do an up, and then we'll see what it is. It should be that one. Yeah. That's an object tracker. No, it's not. Sorry. threadsafe object tracker double colon tracked type reference. At that address, which is, I guess, this. That's the actual type. It's an unlocked of a locked node. Yeah, it's a different unlocked. This is an unlocked of an object tracker of an unlocked tracked object of a locked node. Can I remember that? Unlocked of an object tracker of an unlocked tracked object of a locked node. It's totally different. No, here's something that looks like it. Unlock tracked object of a locked node is the last part, but then here's the track type of that. The tracked type is an unlocked again. Okay, maybe it should accept it, but the fact that it's completely filled with uninitialized data, it's of course not acceptable. So that would be this node. Yep. Item tracker nodes, batch, comma, a reference to a node. Up. Struct. Make shared. Again, I would say that it has to be this one. But, print this. This one is on the stack. It looks like familiar. D480. Where did I print it the last time? It's D458. Yeah. I just printed this. It's not 16. Oh, the tracker's nonsense. Yeah, I forgot how to turn fancy pretty printing. How to turn off pretty printing, and here we nope. It's not working. Maybe we should just use Google. Google knows everything. Disable pretty printer. No. Yeah, really. Now I see what you're referring to. Anyway. tracker is nonsense. And even that is bad. But what we're doing here is being casted to track type. Static cast, however. So what? How? Is the static cast using the tracker or something like that? Even then it should have crashed, right? Cannot read it. I'm so confused what's going on here. No, that's nonsense. We are creating the tracker here. We're creating the tracker. So we are constructing this. This is inside a constructor. It is inside the constructor. Russian guy. Yeah, I'm stuck. I guess track type is graph is graph. D2A8 the pointer to D2 A8, so there's an offset as well, but yeah. I would like to verify that it is really a graph is graph, otherwise the cast is just wrong. So that means that the current object must be a graph. And we are in the constructor of that, so we go up. That's an item template derived from item. It's an item template graph tracker. It's a locked graph. Constructing a locked graph here. We are constructing an unlocked of locked graph. We're constructing a graph. Why am I debugging this? Because that's not the line that goes wrong, is it? This is the line that goes wrong. But okay, it is a graph. Maybe. So this is what I just printed. Yeah, so you have to begin FFF and a lot of zeros. This is a 4. That's the object. So the cast is correct and we just get G0, the root graph. And now I want to go back to this frame. That's frame 0, I guess. And this is done in the constructor of... No, it's not. What did I get here? Stepping while constructing. It's constructing the graph tracker, yeah. It's constructing graph tracker while passing the graph that we are constructing. So this thing is still nonsense when we pass it to this thing. So it should not use it except the address. Okay, so I do a step, then I go into the constructor of of item tracker here. Or not. Item tracker is just an object tracker. So we go into the constructor of object tracker where track type is then the graph. That's still the same thing. Track type is graph. Which is then passed to tracked unlocked pointer. What is the type of that? Looks very much like a pointer. I think here is where it goes horribly wrong. I'm passing a reference to something that takes a pointer. Item tracker takes. Okay. Item tracker is indeed just an object tracker. And this is now a graph reference, and we pass that to the tracked unlocked pointer. What? Oh, right. It's not really a pointer. Well, no, it's not. It's complicated, as they say. This goes wrong. I'm pretty sure of it. That's an unlocked of an unlocked base tracked object, which is defined up here, which uses the unlocked base constructors, which accepts a reference. Don't forget the pointer we should get here. Oh, the pointer came from the fact that I used the ampersand here. I'm an idiot. I did that to just get the type. So I have to ignore that, and then that's the type, tracked, which is an unlocked, but it doesn't print that. Okay, where are we? Step. Yeah, and then it does that. Wouldn't it be nice if I could print a type in the debugger? Linux so desperately needs a new debugger. Yeah, I'm gonna do a step. So I guess it's a graph tracker then T. Or not. Nope. It's something that begins with something that is an unlock base. Dot item is an unlock base. Is that the only thing, or about whatever unlock type is? Something to do with ObjectTracker. No, it's nonsense. That's must be the graph tracker. How do I not understand that? Oh, I'm already constructing this thing. Yeah. We are here, and then I went into the item tracker, which is then the object tracker. Go back. So tracked here is graph, and this pointer is derived from graph tracker. That derived from this pointer is a base class of graph tracker. Object tracker graph. Okay, now define the unlock type here. Track locked, it should be locked graph, and policy type is policy type. So we have an unlocked base of a locked graph. That's the unlock type here. No, we have an unlocked base of track lock type, but it is already inside whatever we are in now. Unlock base tracked object. It's not easy, is it? It's this thing. So we're constructing this thing now. Oh, we would have to. You construct this, you need to construct that. Yeah. Yeah, it took a while, but I think I finally figured it out. We're constructing this. It's not initialized yet. Yet I'm calling mutex on it. And then that's not working because actually it's good, it should work now I think about it. It's a very dangerous and yeah, it should not be. It's, yeah, no, it's like really dirty. But still, theoretically, what's this nonsense? This still looks like D0, right? Still 4, this is still lots of F's, and the rest is still kind of 0. And now I'm casting that to something again. And then calling mutex on that. So this is an unlocked of a locked graph combined with a primitive AI mutex. Now first you get the locked graph, which starts here. And that should continue all the way until here, I think. So that's one, no, like this is the locked graph. And then the second base class is the policy type, which is, yeah, which has an address, of course, which is then equal to the address of that first thing here. Can I print it? To print unlocked dots. Yep. So then the address of that is no. I'm not convinced that this does not have a virtual table though. Would be better to cast it to this. That's really the policy. No, it's the same value. Right, So this is the value that we should get out of the mutex. And then we have to store that in the reference type without accessing anything. You just want that address. Step. And that is literally returning that address, which I just printed already. Yep. And that is, then we take the address and it's stored here. So that's super working, I would say. Can I print it? Yep. Very good. And now, where are we? Okay, so now the base class reference type is initialized. Next we want to initialize mbase, which is simply the pointer to unlocked, casted to the base type. In other words, print mbase, that type is a locked graph, which currently has a nonsensical value. And now we do step, maybe another step. And now it points to the locked graph inside this thing here. There. So that should be equal to this, right? And it is. Yeah. Don't see a problem yet, really. 609. This is debugging code. Now where are we? List 17. Okay, we return from this constructor. This constructor. Now we are constructing the policy mutex. So the policy mutex currently has a nonsensical value. At this address, where was it? This one, right? In this case, it's all zeros. I don't think that changes. Step. State is set to 0. No, it sees an M state. What? Spin lock. This says AI mutex. Why am I constructing read-write spin lock here? Oh, that is the lock of around the inner thing. So What the hell? I don't know. Up. Read write mutex. Oh, this is yeah, something else. We are now constructing probably what comes after the T. The default construction of the second parameter. Don't see it though. Well, yeah. This is the second parameter. Yeah. Second base class, I mean. Okay, well, step. Condition variable, really? No, we're at the end of unlocked. One of the unlocked. I think the outer one. Step. Yeah, now we're constructing a member of I think the graph tracker. Yeah, the graph tracker. So this member. So at this point, we should have a reasonably looking base class. I did go up, so I can print this here. So this is the graph tracker, and it looks now like that's the pointer to the mutex, and the base. Together they make up the tracker, right? Yeah. And a ref pointer for the debugging part. And those two things here are protected with this spin lock mutex. Read write spin lock, which is defined with state of 0. There's a few mutexes stuff. I think that we saw that being initialized. And this is not initialized yet. We are doing that now. There was initialized, was it? Not sure. Okay, let's continue. Yeah, the item here is, I think, the graph which we just initialized, so that should be good. Or it is something else, I don't care. That's to work. Do next. Do step here, why not? Set strict, you just set strict, whatever. Destruction, that's the destruction of this lock here. Yeah. Now we get out of the new. So now it's initialized, whatever TP is. Yeah, I would say this. I think it will be somewhere on the heap. And that should be initialized now. And it is, right? We have this pointer and that one and that one, which I saw before, and this is mostly zeros or only. And this was also initialized. Now I am still kind of why is it pointing to the stack here? Because the tracker, yeah, it's kind of tracking something on the stack, I guess. This is the tracker, so it's just tracking G0. This is this point of G0, right? No, this is the this point of G0. Ah, right. And this should be pointing inside G0. I think, yeah. And, yeah, at the very least it was correct. Kind of interested what that offset now is. So it looks not that small. 168. Wow. Right. So where are we? Step. Let's step out of the make shed. We are already out of it. I went too fast. Item is being constructed. No, so not a member that is element of a class. Absolutely not. What the hell's going on here? No, okay. Now, mysteriously I suddenly construct an unlocked graph. And here I was thinking that we just did all that. What the hell's going on now? Memory owner. Memory owner? Who's the memory owner? Oh, no, I lost it. It's doing it again. I mean, I just did this. Now I'm calling make shared again. What? Or is this it where we are done? I thought we were done before this. Nope, we're doing it again. It's the same thing. Oh, this is utils. Yeah, no. It's now it's making the tracked memory region owner. Yeah, that has its own make shared. Hello, David. Good. Looks totally sane to me. So yeah, that was G0 for some reason. So okay, at least we got some exercise there. And then this one goes wrong. I thought I was doing this one more or less, or not. Nah, the problem was the mutex, that mutex thing. I don't see anything on the find here. Uh, 350. No, it's not 350. That's the other one. It's the 2DA8. Yeah. Okay. Yeah. Well, I don't know. Let's step, I guess. Step into a rectangle node. Oh, you expect. I think it's converting the G0 here. So then we have this pointer. D2, D0. Turning the tracker. Yep, okay. Standard basic string view. What the hell are we constructing here? N0. I don't dare to do anything else but steps. This is probably annoying, isn't it? Using a label node. Rectangle node is derived from label node. Label node takes a weak pointer to the root graph. So we just called that. That's G0, and the string view we also called that. So we constructed these arguments. And that's implemented by just passing it to the node constructor, which is the base class of label node, which is actually an unlocked, which uses the arbitrary arguments thing again, which then in the end should be passed to locked node. In the end, that is T. T is locked node. This one. There we are already on locked node. It's going fast. That looks like the constructor that we're using. Root graph and what is being passed. Item template is constructed and skipped, and we are already at the base class of that, which is item. David, I don't know, half an hour? Why are you asking? If you think it's too long and you have to go, then I don't understand why you ask. I mean, you just go, you know. Well, I'm just curious. You know, alternative is that you need me to stream in order to concentrate on your own work or something like that. That's why you want to know. I'm not even. I'm not anywhere close to fixing my bug. It seems so. Yeah. But I definitely want to watch a movie, so I could even stop now. For that matter. Maybe I should, because I'm getting tired as well. Well, I'm not going to stream that long anymore, so maybe stop now, or at most half an hour more or so. So that I feel like that I will have stopped streaming when you go to bed. I'm addicted to watching YouTube's in bed myself at the moment, and it's really bad. I want to stop. I managed to not do that. I banished my monitor, and then I banished my phone with a lot of effort from my bedroom. And then when I had this new kitchen built here, I slept in a different room with no alarm clock. So I took my phone with me to bed again, just for the alarm clock. Ha ha. And ever since, I'm completely back to zero. I have not been able to do it again. That is, banish my phone. It's not good to have your phone with you in bed. But okay, that is aside. It's you should consider it a problem, a serious problem, if you take your phone with you to bed. No, I go to bed and then I watch YouTube for 3 hours. That's the whole problem. I just can't stop. I've been used to that so long that I just continue until when I've been doing that for 2 decades now, or roundabout. So it's completely engraved in my brain that I keep doing things, including watching a screen of my phone or even a monitor, until I lose consciousness. And then if I wake up again, then just a second to turn everything off, and then I'm gone very quick. But it's not healthy. A good way is, a good sleep hygiene, they call that, is completely different. Completely different. If you ask a professional, then you should, at the very least 1 whole hour before you go to bed, stop watching any screen. And then always go exactly at the same time to bed. Turn the light off within half an hour, and also at the same time. And then if you have a healthy pattern, then you should fall asleep quite fast, like say within 10 minutes normally. And get up at the same time, and then eat breakfast at the same time, get dressed, of course, eat breakfast, have a regular day. At least that's what they told me when I came crawling to the professional, begging them to help me with my horrible day and night mix-up. Abdul, hello. I just came to this video, so please can you didn't? I saw you before. No? Wait. No, apparently not. No, I don't know. Maybe I see ghost. So yeah, tell me the overall topic. Well, normally, most of the time, I'm fixing and compile errors of very difficult compile errors. And right now, I'm the last few hours, I'm debugging at least 1 hour, I think. I'm debugging the program because there is something wrong, not a compile error, but something else. So you can scroll up, there you can see what we have been doing. I've just been, this is a debug session, and I've been doing live this debug session. Still scrolling up, 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 up. Yeah, it starts here. So yeah. Some people really like this before they go to sleep or while they go to sleep. Oh yeah, gaming chairs are, they sit pretty good. And if you sit that much, yes, I'm using Arch Linux. It's too complex. I can't find it apparently. I've been trying the last hour with going with steps and then trying to follow what happens. But yeah, no, it's just I lost my overview while debugging, so it's a failure. Yeah, normally I don't have to debug. This is really an exception. This one bug here, what I'm doing now, it's absolutely ridiculous. I made a lot of very serious impact changes, like absolutely crazy, and that broke my test application. It's a test application. So let me think. Might as well give up here and start over. Run, yes, okay. We have a breakpoint. No. Delete all breakpoints. Really start over. Run, yes. Crash. So this mutex has nonsense data, and it is located on the stack. and the unlocked here points to that value, which I don't recognize, and the mutex itself. Oh, I would put a breakpoint here. And continue 1, 2, 3, 4, 5, 6, 7, 8, 9. Run, yes, continue 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Step. It's something else. Clearly, it's not the pointer of D0. The mutex of D0. That ended in something with 350, right? So you had a 160 bytes, or it was a 200-ish, a few hundred bytes difference between the mutex and the beginning of the object. In the case of D0. So we compare that one to what we are constructing now, which is N0. That minus N0. Dude, fuck off. Do what I want. 56. Yeah, well, maybe because this is a node instead of a graph, because the graph is much bigger. But they definitely belong to each other, right? And I think I should be able to figure that out as well. That the pointer is correct at the very least. So if we print N0 at this point, then it's probably just not initialized. I mean, this is clearly not initialized yet. So I think I just have to do all the stepping that I just did for D0 again, but then for N0. It's probably going faster that time. That's a lot of work. Anyway, to check if this is the correct pointer, we have to find the beginning of the policy. That would be here, right? This one. Yeah. This is the second base class. So I can print simply static cast to that type of this. Fuck off. Of N0. And that gives me that value. Yeah, so the value is again correct. And it's again, or still not anyway, initialized. But we're using it before it is initialized. Or do we? Maybe I can answer that question already. So I get frame 0 backtrace. I can maybe already follow it like this. So we construct a label node. Sorry, a rectangle node, which calls constructor of label node, which calls templated constructor. Passing a weak pointer it doesn't feel right. But okay. templated constructor of unlocked for a lock node, which calls the constructor of unlocked for the same lock node, and also a templated constructor passing a weak pointer and string view. And then at some point we get to the constructor of the lock node itself. And is that not already passed? No, that's the base. That's the first base class of unlocked, and the second base class of unlocked is the mutex. So the mutex is definitely not initialized yet, because we are here. Only after this we are going to initialize the mutex. And then it dares to call add node. Ha 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 ha. Which I'm probably at some point is going to lock the not yet initialized mutex. That's the problem. That, my friends, is the problem. Okay, and exactly why are we calling add node? Exactly why. It's being added to G0, I guess. Yeah, and let's have a look at add node, whatever that is. I think we are making progress, seriously, like definitely making progress here. Soon I will know what is going on. Okay, add node is called from, yeah, one of these. Constructor, well, we are in this constructor, right? It's just a locked node with a what. Locked node with a root graph and a nothing. Yeah, a what here. And it should say where that is. Here, no, 23. .cxx 23. 23. Oh, that's this one. Yeah, of course, we're also passing a root graph. So this is the one that constructs it. And then we call add node on it. Now the parent graph is of course already initialized. That's just G0, so we can get the right access type of that one and then call add node on it. And we are passing the tracker of the current object, which is initialized or not yet. That's a good question. At this point, I think the tracker is already initialized. Yeah. Not 100% sure. If it has the same value, it's initialized, right? Let's just print it till this is line 23. That was here, which is frame 6. Print tracker. Totally sane. So that's initialized. Oops. And then, I mean, even the content is initialized, I bet, which I can also print. I can print, well, let's try the get. Access. Yeah, sane pointers. State is 1 for some reason, but definitely sane values, right? All zeros here. Ref is 1. Nothing of this looks uninitialized. So the tracker is initialized, but the tracker has a pointer to the mutex, which is not initialized yet. And I think I can even do that right here. So the tracker has this pointer to the mutex, and that points to something that is not initialized yet. Actually, I also have one here. We have 2 of them, right? Project music pointer, and again here. Which is which? The tracker is a tracker of unlocked node. The is tracked or unlocked pointer. Oh yeah, the tracked unlocked pointer is an unlocked thing with storing these 3 things. So those are not important, I think. I think that's the one that is uninitialized. That's the one that belongs to the locked node. It would be nice if we could print it. This tracker get. Let me try that like that. Tracker get, and then can I just print it? Nope. It's part of this one maybe. Nope. And that is part of node pointer. Node pointer? No. I don't think that's what I want to use. No. Looks like a goal there. Content off. Damn, that does not look uninitialized. Why? I'm printing a tracker here. Yeah. No problem. I thought I understood it. Apparently I'm not understanding it. Or it is the other one, but I doubt that. This one is on the heap. Anyway. We're talking about N0, right? So it must be one that is on the stack. Maybe I'll just try that one. That one, that works still, of course. Yeah, and then we do this. Star, that is totally undefined. Okay, so it's the other one. Well, whatever. I still don't understand that, but whatever. And now what? I forgot where we were. Abdul, yeah, every day, 7 days a week. It's almost non-stop. Step. Unless I lay in bed, of course, which is 12 hours a day. Not that I sleep, but unhealthy. S. No, frame. Totally forgot where I was. What was I doing? Yeah, okay. So we're passing tracker here down to set the oh, this is inside the what? Inside the track what? Of the node tracker. Okay, that and that. Yeah, this is just using both mutexes. First the first one, and then the content of that is being used to access the second one. And one of them isn't initialized, so that's why it goes wrong. Let me try to understand what track what exactly is doing. So this should be locking the. That's my confusing, you know. This should be locking the mutex that protects the 3 pointers. And then I mean these 3 pointers. Yeah, that one, and that one. So we lock the mutex that belongs to these 3. Okay. Yeah. That's then probably the one here at the bottom. Or that I had at the bottom before this. So somewhere up here maybe. Do it on this one. So I think I have to lock this one in order to get to these 3. And then in order to get access to the object that we are constructing right at this moment, I have to say. So even this is not really initialized yet. We have to lock this mutex, which points to the second base class, which is not constructed at all. So this is half constructed. We are constructing that, and that is pointing to the first base class. And this points to the second base class, which is on absolutely not initialized yet. However, we are already trying to use it here. Trying to create a write access type, which then of course locks that uninitialized mutex. I think I'm going to stop, but I need to remember this. So let me write down here what I just found out. Here on line 208, we are trying to lock the mutex of the second base class of an unlocked while still constructing the first base class. Which is in base basically. Okay. Yep. It's now that was that half hour, so now I'm going to stop. Good night, everyone. Thank you for keeping